This first video has two main focuses. One, you should be able to distinguish between ionic and molecular bonding in terms of their properties, the compounds they make. And then two, actually will be able to describe the processes of ionic bonding versus covalent bonding. So number one, this unit is all about bonding. So to understand this unit, you need to understand what bonding is. Okay, bonding is simply a force that's going to hold two atoms together. Okay, it's some kind of force of attraction that essentially acts as glue that keeps two atoms in the same space traveling around together. Okay, that bond actually contains energy. There's energy required to break any bond. You have to put energy in. So that bond, that connection between two atoms, actually has some stability in it. When we look at atoms versus compounds, why are compounds even forming? Basically, we get some stability by this bond energy. Okay, we get energy out when we make a bond, and you need to put energy back in to break that bond. So that doesn't mean that atoms in themselves are inherently unstable. It just shows in life that there's a certain degree of stability generated by a force of attraction between two atoms. So when we look at ionic bonding versus covalent bonding, keep in mind what's the same between these two concepts, and that's that there is a bond between two atoms that's essentially keeping them together, and that there's some inherent stability formed when they come together. So let's start with ionic bonding. What does it mean to have an ionic bond? Ionic bond occurs when one atom gives electrons to another atom. When that happens, when one atom gives electrons to another atom, both atoms now become charged. The one that lost electrons becomes a cation. The one that gained electrons becomes an anion. And we know opposites attract. So that positive atom and that negative ion essentially stay together and are bonded by the electrostatic force of attraction between their opposite charges. Okay? So again, ionic bonding is when you transfer electrons from one atom to another atom, thus creating a cation and an anion, which are now electrostatically attracted. What's electrostatic attraction? Electrostatic attraction is that attraction between a positive and a negative charge. Okay, so this electrostatic force is what keeps ionic bonds together. Two ions stay near each other because of their attraction. Now, how many electrons are transferred is all driven by the common ionic charges we've already had to memorize. Okay, so sodium gets into a bonding scenario where it can give up one electron to something else. Okay, those outermost electrons, those valence electrons, are going to be given and taken in so that they get an octet on the outside. So whether they give up some so that they come down to S2P6 or gain some to come up to S2P6. That's what's driving it. Now, connecting this to last unit even further, what's going to happen when you have two elements come together is you're always going to have a highly electronegative element basically taking on electrons from an atom with very low ionization energy. So the atom with very low ionization energy will easily make a positive ion, giving up its electrons. And one with high electronegativity likes to draw the bonding electrons toward itself. All that happens here is it draws the electrons so hard, it actually takes them away from the atom that it's bonding with. Okay, so that's ionic bonding, an actual transfer of electrons based on one atom that easily can give up and one atom that can easily take on, and then they're electrostatically drawn to one another because of their opposite charge attraction. So this is a pictorial representation of what an ionic bond looks like with two different atoms. You can see the two atoms are completely separate. They hold their own identities, but they have a relationship here in that they're electrostatically attracted. There's an attraction between the +2 and the -2 charge. So they hang out together. They go everywhere in a grouping, but there's no overlap of the atoms. They reside next to one another. Now, the nice thing about ionic bonds in terms of satisfying giving up and taking on electrons is it doesn't have to be a 1-to-1 ratio, which means when you're making an ionic bond, you don't always have to have one sodium atom that gives up one electron and it's taken on by an atom that also wants one electron. So that example showed here was sodium chloride. Sodium gives one electron to chlorine, making a +1 and a -1, and now those hang out together because they're electrostatically connected. That can happen, but You can also have a scenario like calcium. Calcium wants to give up 2 electrons. It doesn't have to have a substance that takes on 2. It can have a substance that takes on 1 each. So, for example, calcium wants to give up 2, chlorine wants to take on 1, but you can have 2 chlorines take on 1 of each calciums, now creating an ionic bond between 1 calcium and 2 chlorine atoms. Okay, that's possible. So ionic bonds are not always a ratio of 1 to 1. It just depends on what needs to happen. So it's all based on the charge, how much they want to take on and give up. They just need to have the appropriate numbers to do that. And realize, again, these are single atoms we're talking about. On the grand scale of things, we will have lots of atoms available. So it's not confusing or weird to think that there would be 2 chlorines available for every 1 calcium. Okay, there are plenty of chlorines available for the calcium to give electrons to. What are the general properties of ionic bonds then? They form very hard, brittle crystals. Okay, if you bring up salt into your head, salt is an ionic crystal. Okay, very hard, very brittle, very solid. Those crystals, when they dissolve in water, can conduct electricity. Okay, not as a solid, only when it's in water or in solution, but they actually conduct electricity. They have very high melting points, which means it's very hard to break that bond. And the other thing is that because they make these crystals, and I'll show you a picture of it in class, there's this term formula unit, which is going to come up a lot. And I just want you to know on the video what a formula unit is. Formula unit represents the smallest repeating unit in any structure. So, for example, that sodium chloride example, the formula unit is NaCl because they're at a 1-to-1 ratio, where the formula unit for the calcium chloride one is, calcium, 1 calcium, and 2 chlorines. Okay, they're at a 1-to-2 ratio. That's a formula unit. The reason formula units are important is because if you have a salt crystal like NaCl, you don't just have single Na and Cl. You actually have a whole crystal of these, and I'll show you some pictures in class of what this means. But anytime we talk about formula unit, we're talking about an ionic crystal. Now, transferring electrons is not the only way to make a bond. In a scenario where you have 2 atoms that come together and neither one wants to or is able to transfer electrons to the other, we have a second bond that happens. For example, what happens when you both want a toy? Your parents will probably tell you to share. Covalent bonding is when we share. So specifically, a single covalent bond is when we're sharing 2 electrons between 2 fairly electronegative elements that don't want or aren't able to give up electrons that easily. So since they both want electrons, instead of transferring, they come into an agreement where they share electrons between them. They don't get a full 8 then all the time, but they get more electrons than they do when they're by themselves. This is different than ionic compounds because instead of forming a crystal, they actually form individual molecules of things that are bonded together. I'll show this to you in class. I'll show you a picture of what this actually looks like. Now remember, again, in terms of connection to the last unit, these are 2 atoms that are both very high in electronegativity, and they come together and neither one can transfer then, so they have to share. So this is what a covalent bond looks like. Rather than an ionic bond where you have 2 atoms totally separate from one another, the covalent bond has a melding together of the 2 atoms. Those red dots are the nuclei, and that blue cloud there is where the electrons reside. So rather than having 2 totally separate electron clouds, covalent bonds actually come together and meld and create 1 electron cloud. What does it look like when this covalent bond is made? We look at the screen here. This is a covalent sharing of 2 electrons between 2 different fluorine atoms. So two different fluorine atoms can create a covalent bond between them by sharing 1 electron from each fluorine. So again, if you look at the screen, it's these 2 pink arrows, the unpaired electron in fluorine's valence cloud, that essentially, because it's unpaired and there's room in one of those orbitals, it can pair up with another unpaired electron in another atom's orbital and create that overlapping new orbital where 2 electrons reside as a covalent bond. So for the molecule F2, it has a single covalent bond that contains 1 electron from one fluorine and 1 electron from the other fluorine in a shared space between the 2 atoms. So what are the properties of molecules? Now, instead of having a formula unit, the actual formula of the molecule is given to you when you're working with them. It actually tells you what the elements are. Now this means they're not in their lowest whole number ratio because it actually represents the physical, what is being bonded together in a molecule. And again, I'll show you some of these in class. But molecules are really small. They're not as big as crystals because of how many atoms are actually involved in the bond. When you're dealing with covalent bonds, what is bonding together are all nonmetals. So why is that? Well, because for covalent bonds, they're all your more electronegative elements that don't want to give up electrons, and those are your nonmetals. So a covalent bond, or making molecules, are two nonmetals, where for ionic you have one metal and one nonmetal coming together. Molecules also have very low melting points and boiling points, and they're non-conductive in their solid state, and if they do happen to dissolve, they will also be non-conductive. That's it for the initial video. Go ahead and do the form, and have a nice night.